Wanted to talk about coordinates. I will not talk about change of basis here. In one of my old lectures in Blackboard, when you go there in course content, you can call up in chapter 4. I do not recall exactly what section it is, but I think those sections are labeled, and so you will see there the information where I talked about change of basis. There's no homework, nor quiz, nor exam problems relative to the change of basis. There is a problem or two corresponding to coordinate basis. And it's interesting because the way this textbook talks about coordinate basis is a little bit different than what I was familiar with from the old textbook. And so I have adjusted my lecture notes for this, and the problem that I will work will be relative to what you have to work. I just picked a homework problem, which is probably on the quiz, which is probably on the test. So the cool thing about this section is that there's not that much to do, and I think that since there's not that much to do, I don't give you that much. I did recall another problem from a previous section dealing with the rank. It was interesting in WebAssign how they asked you for the rank, but they don't ask for those particular problems that I could pick. They didn't ask for the nullity. So let me do, as an introduction, I would do a problem where you given a matrix, you have to find the rank and the nullity. I did give the theorem that basically said that based on the number of columns that you have, if you find the rank plus the nullity equals to n, the number of columns. So if you have one, basically you have the other, but I didn't in those previous problems state that, and neither did the homework problems ask for that. Since then, I did go back and look at the database in WebAssign for those homework problems. I saw maybe one or two where they asked for the rank, but at this stage in the game, is not that big of a deal. I think if you get the rank, then you get you get the minus as well. So first, and here the definition for the coordinate basis: let S be a basis for a vector space, and let V be the vector expressed as a linear combination of the vectors in S. That is, V is equal to that linear combination. Oh boy, that last one didn't get translated. That's fine. In the textbook, and I think in the book, instead of using the vector V, they use the vector X. So that's fine. So we call the scalars C1, C2 to C sub n the coordinates relative to the basis S. Thus, the coordinate vector of V relative to the basis S is denoted and written as this V subscript of S. In this current textbook, they take that same value and they just call it X sub S, since they're claiming X is the vector that can be written as a linear combination. So before I do that problem, let's just call up um, a problem concerning the so-called rank and and nullity. Excuse me. You take this matrix. Basically, we're going to just take it and reduce it as it is in row echelon form. Reduced row echelon form is what I use on the calculator, and you can see the result there. So we said that the rank is based on when you look at the main diagonal, you look at the leading ones, and so here we have that only one leading one. So that means that the rank is such. So the rank is equal to 1. N is equal to 1, 2, 3, 4. We have 4 columns. So the nullity of that's called the matrix A is equal to 3. So So you have the rank of A is equal to 1, and then the nullity is equal to 3. And so you get the rank theorem that says that the rank of A plus the nullity of A has to equal to n, and n represents the number of columns. Okay, so that's all there. So I just wanted to specify that. Now the problem for this section, given the coordinate vector of x relative to a non-standard basis, this basis that's given here, it says find the coordinate of x relative to the standard basis. So basically this is just a vector x. It's a vector x and it was found by using this basis. So what they want you to do is to find the coordinate matrix of x relative to the standard basis. This is actually a change of basis, but when you change a base to the standard basis, the standard basis, you recall, is e sub 1, 1, 0, 0, and so on to 0. And e sub 2 is 0, 1, 0, and so on. And e sub n, 0, 0, 0, 1. So when you convert a vector to the standard basis, basically you're just taking the basis that they give here, and you're listing it as you would for the linear combination, with the coefficients for the so-called linear combination. The coefficients become these coordinates here, because we call this a coordinate vector. So can you find also the coordinate vector relative to the standard basis, which I think the way they have this problem set up is, to me personally, kind of misleading, but this is how they want you to do it. So we take those coordinates here and we list them. So this becomes 2 times the, let me get the highlighter. So this becomes that 2 times this vector. You have it there. And then it'll be minus 3 times this vector, and then plus 1 times this vector, and then minus 2 times this vector. And then you equal that out, and you get what you want, and you're done. So I think that's pretty cool. So so here we get, this is -2, -1, -4, and -2, and that's it. So nothing else there. That's the only thing that I want to cover with this section. So we'll see you later.